Hello everyone, welcome to our project presentation on e-commerce product classification using text analytics in KNIME. So my group members are Priyanka K, Satish L, Chandan Mishra, and Amit Sahu. So the video will cover four things: objectives, methodology and workflow explanation, results, and conclusion. So the main objective of our project is to correctly classify product into predefined categories, to pre-process textual data using NLP techniques, and to build and evaluate ML model. So starting with uh, methodology. So let's move to section A, that is the data preparation section. We'll feed the data into Excel reader. So as you can see, this is the path location. You can select using the browse option here. And once that is done, you can click on OK. So this file has two columns, category and product description. So this category have four further categories like household, electronics, clothing and accessories, and books. The other column is description for each of the categories. There are over 2,000 rows. So once data is imported, we move to strings to document node, which converts the text into document for us to use. The column filter node, it removes any unnecessary column. Once that is done, we move to section B, to punctuation eraser. So it eliminates any special characters that are there, and then further the number character and filter nodes, they refine the text further. The case converter node, it standardizes the text into lowercase. There's an option to select that here. So once that is done, we move to stop word filter node. So it removes common words that don't add any value to this model. Then the snowball stemmer node, it reduces the word to their root form so that we'll be able to uh, know the meaning of the word and use the classification in a better way. The term filtering, this is the meta node. So it keeps only the relevant words based on document frequency. So here it clears the bag of words and further refines it further. So let's get out of this meta node. Moving to section C, that is, we have the document vector node. It converts text into numerical vectors. As you can see here, that the text, there's a vector created, and there are about 934 columns now. The category to class node assigns label for machine to learn, and the color manager node, it just assigns four colors to the four categories for us to being able to recognize them in a better way. The column filtering node ensures that only relevant features are used. Further, we move to section D. Here the data is split into training and test data set. So we employ a 70-30 split. So 70% of the data is used for training, and then 30% will be used for testing. So the training data is fed to decision tree learner node. So if we open this node further, it is trained using the KNIME decision tree learner. And if we see that how each word is being classified, it gives us the logic. So if the word author is present and if the value is like greater than 0.5, it will be classified under books. Then the word winter, it will be classified under clothing and accessories. belt, again, clothing and accessories. So we can keep moving below, and it will keep giving us the logic that it has used to classify the things. That unisex word is classified under clothing and accessories. Bow, again, under clothing and accessories. So this is the logic which is being employed here. So let's move to the decision tree predictor. So here the predictions are being made, and the test set is also fed along with the decision tree output. If we check the ROC curve for household, the AUC value is 0.948. That is 94.8% of the times our model was correctly able to classify the household category. We can change that from here. If we select clothing and accessories, and we have to select clothing and accessories here as well. So for clothing and accessories, the AUC value is 97.3. Similarly, we can check for all the 4 categories. And this is the confusion matrix. This is the confusion matrix. The overall accuracy of the model is 89.482%. And out of all the items, the correctly classified ones are 536 and wrongly classified are 63. We'll discuss this in detail. So this gives the accuracy of all the categories. So the overall accuracy of the model is 89.48%. And discussing sensitivity or recall. So sensitivity represents the ability to correctly identify actual positives. Higher sensitivity value means fewer false negatives, that is missed classifications. And specificity measures the ability to correctly identify actual negatives, ensuring the model doesn't mistakenly classify other products into a given category. So if we check, clothing and accessories has highest sensitivity or recall of 92%, which means that around 92% of the clothing items are correctly classified. And household item, electronic items has the least sensitivity. Moving to specificity. So electronic items have highest specificity value of 99.11%. It means that it is least likely to be confused with other categories, while the household category has the least value, means that there's a misclassification observed here. Like, so in conclusion, model is pretty accurate. There's still room for improvement. We can use neural network, which gives more accurate results, but again, the logic won't be explained uh, there, that which is being used. So yeah, that would be all from our end. Thank you for watching our presentation. Thank you.